Oh, there we go. Wow, that was fighting me. Okay, I'm going to keep this fairly quick. But I want to run through the post-lab calculations for the titrations lab. There's 3 kinds of calculations you have to do. The first one, which is going to be kind of the most involved, is you have to calculate the molarity of your acid for every trial. For every trial, for every unknown. And you're going to be comparing those later on. Okay, remember, part of your purpose here was to figure out if the concentration posted on the bottle was the actual concentration or not. So that's kind of where we're going. So we're going to be using the same equation you did for your pre-lab calculations, which is basically just the dilution equation, but it's acid equals base instead of initial equals final. Now, the molarity of your base, there are 4 possible numbers for this. This is the number that was on your bottle, the bottle of base that you've been using, the gallon jug. All of you should have 2 values for this that you have to use. Those of you at one bench are going to have different values than the 2 at the other bench because I had 4 different solutions, but you should each have 2 of these. Most of them should be the initial values, the red and the blue, but some of them are going to be the orange and the green, the new values from later. Volume of your base is the volume that you added. It's the volume of base that was added in each trial. This is what you've been tracking on your data table. Volume of acid that was used was 2 milliliters for every trial. You can assume it was 2.00 milliliters for purposes of sig figs. It is possible that you have some variance there, especially since this is the first time you guys really used pipettes, but we'll address that later. And then the concentration of your acid is what you're actually calculating. So you're going to solve for this. This marker is apparently dead. Hey, hot dang, this is going to be fun. You're going to solve for the molarity of your acid. So you'll divide this side by the volume of your acid, or divide this side by 2 each time. And that's going to give you your concentration of acid. You need to do that for every trial. I would suggest that, and this is going to be good practice for you because you'll have to do this in college, instead of trying to just do this 25, 30, however many times you need to do it, including the trials you threw out. You have to do this for every trial. Make a spreadsheet. Like, build a spreadsheet in Excel, or I guess Google Sheets, to do this calculation for you. 1 column for the concentration of your base, 1 concentration for the volume of your base, and 1 concentration for the number 2. And then just drag that equation out, and it will calculate this for you for every single one of your trials all at once. Then all you have to do is put in your data, and it will do the calculation. You can do the same thing for your percent error, because you're going to have to do that for every single trial too. For your percent error, we're still using the same percent error equation that we did last year in our 2 solutions labs. T is the theoretical value. That is the value that is on the Erlenmeyer. Okay, so you're going to have 1 of these for each unknown, and it's going to stay the same for that entire unknown. E, your experimental value, or the actual value, the value that you calculated in your data, is MA. So this is the number that you're actually calculating in the first half of this. Okay, then you'll do this calculation, theoretical minus experimental over theoretical, times 100 will give you your percent error. And this can just be part of that same spreadsheet. Put your T values in as one of your constants, and then you can just have it calculate all that stuff for you. The last calculation you're going to have to do is a new calculation. Okay, and this is percent difference. We want to compare the percent difference from your largest MA to your smallest MA for every trial. So what one is going to be your E's only. We don't care about your T's. Your E's only. Your smallest value and your largest value. And it doesn't matter which one you put where. I guess it would actually be better to put your largest value first. That'll make the absolute value bars unnecessary. But largest value minus smallest value divided by the average of those two. Not the average of all of your trials. Just the average of those two. So, for example, for Logan's data, you'll have a largest value, a largest MA that you got for Logan, and a smallest MA that you got for Logan. Okay, that'll be your top, the difference between those two. For the bottom, when you calculate your average, you don't want the average of all of your trials. It's just the average of your largest and smallest Logan value. Logan, by the way, was LMG. Okay, and then rounding it out, we have to turn it into a percent, so times 100, and that there's no equals here, but there's supposed to be an equal sign here. Multiply that by 100, and that will give you your percent difference. You only have 1% difference per unknown. Okay, you'll have a percent error for every trial. You'll have an MA for every trial, but you only have 1% difference per unknown. So you only end up with 6 of these. If that didn't make any sense, if there's something that I didn't mention or skimmed over too quick, let me know. Give me a timestamp on the video so I can go back and look at it, and I will try to get back to you on that. At the very least, you should be able to do this or start working on your spreadsheet. And if you don't understand how to do the spreadsheet, you're not real sure what's going on with this, let me know that as well, and I can prep some time for us to go over how to do that in Excel if you're not real familiar with spreadsheets. Because it's how to organize that stuff is also something that you have to learn. So I will go through that if we need to. That's going to wrap this video. I think I'm going to be back tomorrow. Fingers crossed. And I hope this helps. Have a good